All right, so we want to do number 42 in 6.3, which is talking about the Heaviside function, which is defined how?
When less than 0, it's a flat line.
Okay, so when x is 0, it's
0,
0 output. And when x is bigger than or equal to 0, the output is 1. Okay, what good is this? You guys need a picture? Picture this thing for me.
Is it kind of like an exponential?
No.
Or is
That's
it
what I was
No, the output's only two things, right?
Yeah.
The output's 0, right? So the function 0 looks like the x-axis, right?
Oh, these straight lines.
So it's a flat line, right,
Okay.
over the x-axis until we get to 0, and it doesn't include that point. And then what is it after we get to 0?
1
Then it jumps up to 1, and it's
closed
closed dot, and
to infinity.
yeah, it just is flat, right? It's constant. So this thing is really kind of a boring looking function, right? This is h of x. What is a Heaviside function good for? Like,
How many apples do you have after you get one?
yeah, kinda. You guys see that? This is like, you don't have an apple until time 0, and at time 0, someone gives you an apple.
And that's the last
How many apples do you have as a function of time?
Sure has to do with electronics and whatnot too.
Yeah, this thing's super good for electronics because this model's a switch, right?
Oh.
Like, it's off, and then it's on. And so if we want to do more than one switch, right, we can add these together or something. You guys see that? Yeah, so these are kind of how you run differential equations where nothing's going on and then something happened. You guys see that? This thing's basically an on-off switch. It comes up all the time in anything where you have some kind of switch going on. So what were they asking? They're asking for some graph transformations. So the first one is what?
Down by 2.
Okay, so I'm going to just say a of x, right? Is supposed to be h of x minus 2, which you guys are telling me is what?
Down by 2.
Down by 2. So,
Yeah, shift all the points down by 2.
yeah, so just take your two lines, right? So I got this one that's at 0, right? And now, after I shift down by 2, it's going to be at negative 2. So maybe I should label, right? 0, 1, negative 1, negative 2. So there's that half. Should be noted that this was also part of h, right? So now I've got, what, that's half of a. Where's the other half?
Start negative 1.
Oh, good, that's at negative 1, right? Closed dot, running this way. So these two bits are a of x. Now I need some colors. All right, what's b of x? B is, okay, so b is h of x plus 2, with the plus in the argument. So what's this thing going to do? Good. This should be a, wait, left or right? I always forget. Left?
Before
Cool, that's adding before the rule, so it goes left, backwards of what you would think. So I need to take this whole picture, shift it left 2 units, which means that my jump is going to now happen where? Good. Jump happens at negative 2 instead of at 0. So up here till I get to negative 2, jump. You guys with me on that? Okay, so what's the use of this one? This is b of x, right? The red.
you're wanting to switch something before.
Good. Yeah, this is a switch that turns on at negative 2 instead of 0. Why might that be useful?
Because something happens at negative 2.
Yeah, because something happens at -2, not at 0. So maybe you want to turn it on beforehand. You guys kind of with me on that?
Like time 0 is when you enter the room, but there's a sensor that goes off 2 seconds before you enter the room.
Yeah, sure. Like time or something. Let's see. So now I need C of x, and I'm out of colors, so I'm dotting this one.
Oh.
This is going to be super confusing.
Like acetone.
Right? C of x is what? What do they want me to do for C?
-3.
Oh, God. Negative? Oh, no.
You sure want to do that? Yeah.
There's a blue marker
There's a
over
blue
here.
marker right there.
Really? Oh, yes.
Oh, there you
Hit
go.
me.
And a black one over there too.
I got a black one in my pocket.
I don't think
Okay.
I've ever given back my ex book.
C of x is
-3 times
-3 h of
-x.
negative, uh-oh.
And then that's quantity, and then +4 on that side.
This?
Yeah.
Okay. So I got -3 h of -x plus 4. So what are you thinking on this one?
You flip this. You flip X and Y.
Okay, I'm going to need to do this one over here, right? Okay, so this bit here is telling you that you've got a
Y axis.
a horizontal flip, right? Then what's this guy?
X-axis.
Stretch.
Okay, so there's two things here, right? There's a vertical flip because of the negative sign.
Yeah.
There's a
Vertical compression.
vertical
Stretch.
stretch,
Outside the rule.
right? It's after the rule, so it is operating as a stretch. And then this guy here
Up by 4.
is a up 4. Okay, which order does that stuff happen in?
Horizontal flip.
Yeah, just do it from the inside out, right? You guys see that? There's only one thing happening before the rule, and that's this horizontal flip. So everything can just go outside. So let me draw. So H looked like this. Right, so that's H. Then I need to do what? Horizontal flip. So that's going to look like what?
Arrows just
Do
going
the opposite direction.
Arrows go the other way.
Yeah, points are.
So what does this thing model? This is H of minus x. What's that good for?
Something was
Switching
on
back.
and you shut it off.
Yeah, something was on forever and then we shut it off at time 0. You guys see that? Okay. Now, vertical stretch, right? Okay.
One go to 3, 0 stays there.
Okay. So, what do I do different?
You flip a 3 instead of a 1.
Yeah, good. Now that's 3 high instead of 1 high, right? Okay, so this is 3h of minus x. Then what?
You flip them.
Flip over the x-axis.
We need to flip over the vertical. Oh Lord. Okay, so what's that going to look like?
The open dotted 0, 0.
Okay, so the 0 part's going to stay the same, right?
Yep.
And then, yeah, the other bit just goes to -3, right? Guys cool with that?
Yep. Then it goes up by 4.
Okay, and then I need to lift the whole thing up 4. So this was -3h of -x. And now, if I lift the whole thing up by 4,
It's gonna go up and start at 1.
okay,
Top of 1.
so that's 1 high now, right? So I took this bit, shifted it up 4. Where's the other bit end up?
4.
Up here at 4. So the blue bits, right, are -3h of -x plus 4. Bam. Done. Cool? Questions, concerns, Steele? Not about this. Cool.